Um, I'm Mohammed Salman Siddiqui and I'm explaining the second part of Lab 4. Now we have to make a controller display of 7 segment and then demonstrate it via with the help of FPGA. Starting off with this module, first of all, these are our inputs and outputs. So we have this output because which is of 6 bits as our 7 segment display of 7 is which is of 7 bits, which as our 7 segment display is of 7 cathodes, right? And there are altogether 8 display on the DDR4 board. That's why we have used 8 enable pins, and we are just keeping one so that we could just enable make the other inactive and only use to display which we want to use to display in our controller. Then there are 2 inputs for 4 bits for each corresponding 7 segment display, and there is a clock which is being given by the board itself, FPGA board itself, and there is a reset button. So starting off with that, we have, as we have in the previous module, we have encoded it and ran it hex to 7 segment in the previous part, and now we are just declaring it and to be used in our display controller, in which there was one output of those cathodes, and there was one input of 4 bits. So we have declared that, and then in order to further instantiate that and later in the system, we have just declared an internal signals of 7 bits. Now there is a counter, and as the frequency of the FPGA is 100 megahertz, and we want the refresh rate as described in the lab manual to 500 hertz. So we 500 hertz. So we have divided with 500. So and the answer is 2 0 0 0 0. I mean 20 multiplied by 10 to the power 4. So in order to change and refresh the value to 500 hertz, that's why we have declared the maximum count integer to be this value. Then at the toggle point, we have also declared a toggle signal which is used to control that which 7 segment display is active at a time. Right now it's 10, so 7 segment displayed, and when it will be toggled, then other 7 then when the bit would be changed of the toggle, then another 7 segment display would be active. Moving on towards the main body of the code, we have just instantiated the 2 components as we declared earlier, and then we have just toggle the enable pin as it's 0. So when the LSB is, if this is 0 specified pin, then this 7 segment display will be turned on, whereas when the MSB of this one would be 0, then this 7 segment will be displayed, and all other 7 segment displays are given 1 to remain inactive. After that, let's move towards the toggle control count process. At the every rising edge of the clock, now this is being working. When the reset is high, then the toggle, all the value which is over there, toggle remains the toggle. Whereas if the reset, if the counter is reaching the maximum value, maximum count, which is 200,000, then it was not it is negated. I mean, its toggle become non-toggle, and this process ends. This toggle process was already being defined, in which when the toggle is 1, non-1 is 1, then then segment 1 is being displayed, whereas segment 2 is being displayed. There we haven't modified this part; it was already being done for us. Moving on towards the counter process, when it's also working on the rising edge of the clock. When the reset is high or the count is 1, maximum count is 1, then the counter is given the value 0. Whereas if that's not true, then the counter is being incremented. After this code was being simulated, was being checked for the errors in the model sim, and then it was being imported on the FPGA board. So now let's move towards the demonstration on the FPGA board. At this time, every pin is 0, right? These 8 are the input pins. this for the one segment display, these four, and these four for the other 7-segment display. So and this is the reset button. So whenever you're clicking the reset, it's toggling the one 7-segment display, because at a time only one is active. Now it's 0. Let's give 1 to this. This is 1. And for the other 7-segment display, let's give 1 to this. So these are 1 1. Let's check to the another boundary condition, which is F for this and F for this. So this is FF. Now when we are just switching it, we're getting 9, because 10001 is 9 and 111 is F. Then 9 over here again. Then here 1, 3, 2, 29. So it's working fine. Now let's move towards the reset pin. Whenever you press the reset, right, it becomes it just will give you it just reset and gives you the value, because it's already in the input. And when you again press the reset, so at a time 1 is only being resetted, right, because at a time 1 is active. And this, as we know, that this is constantly blinking, but as the frequency is very high, so naked eye, with our naked eyes, we can't just feel those toggling pins. So this was C, this was 0, and you can check it on any other. These are few inputs where I'm demonstrating, and it's working properly on all the inputs. So this marks the completion of the second part of lab 4. Thank you.